The most brilliant physicists in history didn't succeed because they were smarter than everybody else, but because they understood conceptual problem solving. Unfortunately, this is something that most physics students never see. In this video, I'm going to show you exactly how to help your student identify key terms and ideas that unlock problems, when to apply math versus when to use a logic solution, and the conceptual approach that transforms struggling students into confident problem solvers. Hi, I'm Robin with Centripetal Education. One of the traits I've observed over 35 years of teaching physics is that students often try to jump right into the solution without really thinking about what they have to do. They never conceptualize the problem. This really is a result of never really experiencing how to solve a problem. In fact, our schools frequently teach a very simplistic method of problem solving. And as I stated before, physics doesn't exactly follow that line. In most of their academic career, students are shown that they look for the formula that's going to work, they put numbers in, and they plug and chug. And they try to use a memorized method, a memorized set of steps to solve this problem. And while that may work for one problem, it doesn't work for the next. And that's because the problems are slightly different. They're not conceptually the same. Now, what do I mean by a novice approach? Well, novices, when they approach problem solving, they typically want to, number one, search for formulas that contain the given information, the given data. Number two, they focus immediately on numerical values. Number three, they work backward from the answer. They know what the answer's got to be, what the units are that the answer has to be in, and they work backwards trying to get there. Number four, they try to apply rigid procedures that they've memorized. They don't always work. And the fifth thing that we see very common with novice problem solvers is that when it doesn't work, they get very frustrated and they think there's something wrong with them, or they just want to quit. So how does an expert go about solving a problem? They begin by looking at the qualitative analysis of the situation. Now, if you're not sure what qualitative means, I always thought of it this way. You have qualitative and quantitative. Quantitative, is a number. Qualitative is the descriptions, the words. So an expert problem solver is going to take the time to think about how to solve that problem in words. Their thought process might go along the line of, okay, I've got this information here, and I know I need to have this specific answer over here, and I know to get there, I'm going to have to take it through these transformations. I'm going to have to do this kind of stuff. I can find the answer to the missing variable by applying this concept here. They do this all before they ever start putting things down on the paper. By doing this qualitatively, they're going to identify the principles and concepts that they're going to need, which oftentimes, as I mentioned, will give them a piece of data that they didn't already have, that they might need to solve that problem. The next thing they're going to do is they're going to create a simplified model. Now, this could be anything from, if we're just doing a homework assignment, for example, it might be drawing a simple picture on my paper and labeling everything I have and trying to figure out where things go, but make it simplified. So maybe if we're dealing with a bunch of forces, we draw just a simple box and we put all the forces acting at the center of mass. That's one example. Now, because they've gone through the process of already coming up with the principles and the concepts they're going to need, and they've already come up with their qualitative analysis of the problem, they're then going to create a roadmap that's going to take them from where they currently are at the beginning of the problem to the solution of the problem. They're also going to use multiple representations of the data. This could be a picture, it could be a graph, it might even be a mathematical equation. So now we're at the point where we understand the difference between a novice problem solver and an expert problem solver. So the question is, how do we build our skills? How do we go from that novice problem solver to the advanced problem solver? So we have a series of steps that we can follow that will take us along that journey. We're going to start with what we call deliberate practice. And the way this works is we're going to go through and watch other people solve a problem. It may seem counterintuitive when we're saying you should watch a video to learn how to do something, but we do that all the time. How often, when we're trying to learn how to do a new craft, let's say, do we jump over to YouTube and watch it there? This is the same thing. We're going to go to a set of videos that's going to walk us through that particular solution. A great place that you can find some of these videos is actually in our Solutions Library membership. This is exactly what we have. Hundreds of problems that are solved by advanced problem solvers who are going to be able to walk you through and explain exactly what they did, why they did it. They're going to show you the rationale behind things. And it's really a useful tool for anybody in a physics program. If you'd like more information, there's a link down in the description. After we've gone through the process of watching the videos and seeing how these problems are solved, the next step we could take is to do partially completed problems. And what I mean here is this is a problem that is going to be set up where a lot of the pieces are already filled in, but there's a couple of missing sections that you have to take care of. And by doing this, you're able to go back to what you saw in the videos, and then you can apply that into the problem you're currently working on. Things that would be in this nature are problems that leave calculations for you to handle. Or perhaps you're given a problem that's already all there, but you're told there's an error, and you have to see if you can find the error that was made. The next thing we're going to do is we're going to use multiple representations. So we want to be able to look at a problem and then set it up as a, verbally explain the problem. We want to be able to draw a picture that explains the problem, maybe create a graph that explains the problem. So the more ways we can express the problem we're dealing with, the better off we're going to be. Now the next one is a little subjective here, and this is where you want to teach the problem or the method of solution to somebody else. Now there's several ways this can be done. The first way you can do it is if you're in a co-op or you have a small group, you can teach it to them, or a study group, for example. Or maybe you teach it to your parents or your siblings. Or one of my favorites that I always used when I was growing up, I used to teach it to my dog. The last thing we're going to do is we're going to embrace productive struggle. Now, I don't mean go out and find the hardest problems you can find and beat your head against the wall. No, that's not productive. Productive, though, is taking a problem that's a little bit beyond where you've worked and try to see if you can figure it out. In a textbook, depending on the books you're using, sometimes they have different level questions in the book. And if you're seeing you're getting all the level 1 questions, go to level 2 or level 3. Try to challenge yourself as you're going. As with any learned skill, guided practice is still probably the best way to improve your ability and continue to grow. When you put all this together, the problem solving and techniques that are left out of the books, you really end up coming up with an entire homeschool physics solution. I'm going to talk about mine in the next video. I'll see you there.